Find the linear approximation for the cosine of x function at the point pi over 3 and to calculate the cosine of 1. I mean, the question is this normally. What is cosine of 1? What is cosine of 1? To find this, it says that since pi over 3 was 1 point, I forget, but it was something like that, which is greater than 1, and we know that this value, which is cosine of pi over 3, is equal to, cosine of 60 degrees, which means 1 over 2. This is 0.5. I know this. Use this information, and it's clear that cosine of 1 will be something greater than 0.5 if you look at the graph. So how can you find this? Formula is this: cosine of 1 approximately f at x0 plus f prime at x minus x0. Let's check the formula. F at x0, f prime x0, x minus x0. So f prime, let me clean this, f prime at x0 times x minus x0. This was the equation of the tangent line. Actually, what are we doing? Do you know? What are we doing? Do you know? We do this. Normally, f of 1 is equal to this one. Are you looking? I'm saying very important thing right now. Normally, f of 1 is this one. So we want to find what is this based on the fact this is 0.5, which is cosine of pi over 0.5. Now, what are we doing, dear students? I am drawing a tangent line here, which is the point I know its value, its y value. When I draw the tangent line, I am saying that what will be image of this one when I go there? So which is now in my tangent line L1. So I am saying that this difference between the L1 and my question, it's so small. I can regard as the result of cosine of 1 as result of L1. So it is simple to calculate L1 on the line. It's not difficult. So what we say, L1, which is cosine of 1, which is my question, is equal to y0 plus f prime, or instead of y0, let's say, like the book, let me use the same notation. This is equal to f at x0, which is y0, plus f prime x0, which is slope, x minus x0. This is almost same with this. Same thing, okay? So what is f at x0? F at the x0, which I know its value, which is pi over 3. And then f pi over 3 means cosine of pi over 3 plus, what is the derivative of cosine? Can you tell me? It is negative sine of x. So x is now pi over 3. I put it times x minus pi over 3. And finally, cosine of pi over 3 minus sine of pi over 3 times x minus pi over 3. Now, what is my x in this case? What is my x? So I want to find cosine of 1. So my x must be 1. So let's see here. Here you see now 1 minus pi over 3. Here, the x at the end, we have to put 1. Why? I am looking for cosine of 1. So all the calculations, which is cosine pi over 3, negative sine pi over 3, where is it here? Cosine pi over 3, negative sine of pi over 3, and then x minus pi over 3. When I put everything, I got the final result as 0.5409. So when I use the calculator, for example, what am I going to get? Let me try. Cosine of 1, it's equal to, let me read to you by using calculator, 0.5403023023059. So now I haven't used the calculator. I mean, I didn't use cosine of 1 and enter. No, I didn't do this. I used the approximation and I got this result. Okay, this result comes out after this calculation. Of course, dear students, you are not doing this by yourself. You will write them in Excel or you will write them in any computer language programming. Okay, so directly, automatically comes this result by itself. And when you use the Python, when you use the C++, when you use something, it's not easy to take the logarithm, sine, cosine always. Or when you take it, it's not being accurate. Why? You know, the calculator, for example, they have 10 digits. Or the computers, they have, let's say, 15 digits, 20 digits, 80 digits, whatever. So if you want to get the accurate information, you have to use the algorithm.